Okay, so for Module 2, we're going to start off here with Lesson 1. We're going to be expressing metric length measurements in terms of a smaller unit. So going from a larger unit to a smaller unit. Then we're going to model and solve some addition and subtraction word problems involving this metric length. So what I'm going to do is we're going to first start off on this left-hand column here. Okay, and then we'll go over here and we'll do the right-hand column. Okay, so we're going to first start off with kilometers and meters. So 1 kilometer equals 1,000 meters, okay? And that prefix kilo is a big clue for 1,000, okay? So then obviously 4 kilometers would then be 4,000 meters, and 7 kilometers is 7,000 meters. Okay, now to go in reverse here, instead of 18,000 meters, okay, we're going to actually divide by 1,000 this time and get 18 kilometers. Okay. Now, what we're going to do is we're going to jump down here to number 2 so we can stay with kilometers. Okay, and you're going to see that we're going to convert the measurements now. So, what we're going to do here is we're going to take our 3 kilometers and turn it into 3,000 meters. Okay, now we're going to add 3,000 plus 312, and that gets us 3,312 meters. Okay. Now, same thing for letter B here. 13 kilometers becomes 13,000 meters. Okay. And then add that to our 27, and you see that we have 13,027 meters. Notice how there we have to put a 0 in that hundreds place. Okay, that's very important that we put that 0 in there. We only have 2 digits here in our meters. Okay, so we have to put that 0 in front of it. Okay, same thing here with letter C. We have 915 kilometers, so that's 915,000 meters. Plus 8 meters gets us 915,008. Okay, so now this time when we add our meters, we have to put 2 zeros in front of it. Okay, because there's 1,000 meters in a kilometer, we sometimes need to put these zeros as place markers so that we can keep our kilometers out here in the thousands place. Okay, so now let's jump over here to centimeters. Okay, so now a meter is larger than a centimeter. There's 100 centimeters in a meter. So then 3 meters obviously will then be 300 centimeters. Okay, so we can sometimes picture it of putting 2 zeros after our meters. So now when we get to letter G, we see 80 meters. Okay, so we're going to multiply that by 100, and now we get 8,000 centimeters. So you're taking your 80 and then putting 2 zeros after it because we're multiplying by 100. So now this time we're going to go in reverse. So now our 12,000 centimeters, you have to imagine that we're dividing by 100. So you know that from our place value work, we're going over 2 places. So our 1 and 2 are going to go over 2 places. And that's going to give us 120 meters. So it's almost like we're dropping off 2 zeros to make sure that our 1 and our 2 go over 2 spots. Okay, so now let's do some conversions. Okay, so now 3 meters again, going back up here, is 300 centimeters. So now we do 300 plus 56 and we get 356 centimeters. Okay, moving on to the next one, we have 14 meters. Okay, so we can kind of picture 14 and then 2 zeros because we're multiplying by 100. So now we have 1,400 plus 8, and that gets us 1,408. Okay, so moving on to the letter F, our 120 meters, put 2 zeros after it, now we have 12,000 centimeters. Add that to the 46 and we get 12,046. Okay, so now for letter number 3, letter A, what we're going to do is, if you notice, we have kilometers here, but we only have meters here. So what we're going to do is we're going to take that 4 kilometers and convert it into 4,000 meters so that we are subtracting like units. Okay, so now we can go through and do our subtraction, and we need to do some decomposing here in our tens group. Okay, so now we have 10 tens minus 8 tens. Okay, and we get 3,720 meters. Okay, Now, letter B, we have meters and centimeters. Okay, so what we're going to do is we're going to take our 1 meter 15 centimeters, combine it and convert it into 115 centimeters, minus 34 centimeters. Okay. Go through and do our subtracting. We get 81 centimeters. Okay. Now for letters C and D, we're going to express our answer in the smaller unit. So we're going to take our kilometers and meters, and we're going to convert it into the smaller unit. Okay, in this case, meters. So we're going to take 1 kilometer and turn it into 1,000 meters. So now we have 1,431 meters. We're going to add it to 13,000, because that's how much 13 kilometers would be, 169 meters. Okay. So we can go through, add these up. We get 14,600 meters. Okay. Moving over here to letter D, we need to convert to centimeters. So our 231 meters, 31 centimeters becomes 23,131 centimeters. And our 14 meters, 48 centimeters becomes 1,448 centimeters. Okay, now we can go through and subtract. We've got some decomposing already over here in the ones place, and then again in the tens place, again in the hundreds place, and we end up with 21,683 centimeters. Okay, all right. So E and F doesn't say to put it into any specific unit, so we can actually just leave it as it is with mixed. So what we're going to take 67 kilometers, 230 meters, plus 11 kilometers, 879 meters. Okay. Now we're going to add these up. Okay. So we have 1,109 meters. Okay. But that's over 1,000. So that means we have 1 kilometer and 109 meters. Okay. So now moving over here to our kilometers, we add that up, we get 78 kilometers. But we also have this kilometer over here. So our final answer is 79 kilometers, 109 meters. Okay. All right, moving on over here, we have some subtractions. So we're going to take 67 kilometers, 230 meters, minus 11 kilometers, 879 meters. We're going to take the same numbers, but this time we're going to subtract. Now, we start off with the lowest place first. So we look at our meters and we see that we have a problem. Okay, we have a larger number on the bottom than we do on the top. So that means we need to do some decomposing. Now, it's a little bit different here with our measurement. So what we're going to do is we're going to actually decompose 1 of our kilometers and turn it into 1,000 meters. Okay, now we have enough meters to subtract. Okay, so now we can go ahead and do our decomposition. And we get 351 meters. Okay. Now we come over here to our kilometers. Now we have 6 minus 1 in both places. So our final answer is 55 kilometers, 351 meters. Okay. So moving on now to some word problems. Okay, so we take a look at number 4. We're going to use a tape diagram. We're going to solve using a simplifying strategy or algorithm. And then we're going to write your answer as a statement. Okay, so same thing that we always do. So the length of Carter's driveway is 12 meters 38 centimeters. His neighbor's driveway is 4 meters 99 centimeters longer. Okay, notice longer. How long is his neighbor's driveway? Okay, so we have Carter and we have neighbor. Okay, so we have a measurement of Carter. Okay, we know his neighbor's driveway is longer. Okay, and we have the measurement for how much longer. Okay, we're trying to solve for the length of the neighbor's driveway, so we need this amount right here. So what we're going to do is we're going to take the length of Carter's driveway plus the length of that extra amount, and we're going to add those up. Okay. So we see right away when we add up our centimeters we have over 100. Okay, so that means we have 1 meter 37 centimeters. Okay, and then when we add up our meters we get this amount. So now our answer statement is his neighbor's driveway is 17 meters 37 centimeters. Okay, because we combine the 16 plus the extra one from over here. Okay, number 5. Enya walked 2 kilometers 309 meters from school to the store. Then she walked from the store to her home. If she walked a total of 5 kilometers, how far was it from the store to her home? Okay, so now we see the word total, so that means we know that we're going to be doing some subtraction. Okay, because they're giving us a total of 5 kilometers. Okay, now school to store, we have 2 kilometers 309 meters. We need to know store to home. So we're going to take our 5 kilometers minus 2 kilometers 309 meters. Okay. Now, setting this up, right away you see over here on our meter side, we don't have any meters over here to subtract from. So we're going to decompose to get 1,000 meters over here. Okay, so now we can go ahead and subtract. Now, we have 0 minus 9 in our ones place, so we're going to actually take off this 100 tens and make it 99 tens. So we have 10 ones. 10 minus 9. Okay. So we get 2 kilometers, 691 meters. So it was 2 kilometers, 691 meters from the store to her home. Now Rachel has a rope 5 meters 32 centimeters long. It was cut into 2 pieces. One piece is 249 centimeters long. We need to know how many centimeters is the other piece. Notice here we have the word centimeters. We need our answer in a specific unit this time. So we're going to take our total length, which we know is 5 meters 32 centimeters. But since we need our answer in centimeters, we're just going to go ahead and convert it right into 532 centimeters. Okay, one piece 249 centimeters long. We need to know the other piece. So we'll go ahead and do our subtraction. Okay, do our decomposition. We get 283. So the other piece was 283 centimeters. Okay, next, Jason rode his bike 529 fewer meters than Allison. So Allison rode longer. Jason rode 1 kilometer 850 meters. How many meters did Allison ride? Notice again we need our answer in a specific unit of meters. So we're going to take Jason and Allison. Okay, so we have an exact measurement for Jason over there as 1 kilometer 850 meters, but we're going to convert that into meters since we need our final answer in meters. Okay, so we have 1,850 meters. Okay, so now he rode his bike fewer meters, which means Allison has a longer tape diagram here, and we see 529 meters goes there. So we're trying to solve for Allison. Okay, so we can see from our tape diagram that we're going to need to do some adding. Okay, add that up, we get 2,379 meters. So Allison rode for 2,379 meters.